You have probably heard about intermittent fasting. Maybe you have tried it yourself. Maybe it worked for you. Or maybe you are wondering why you have been fasting but still not losing weight, still not seeing the changes everyone talks about. You follow the rules. You skip breakfast. You hold off until noon. You feel hungry. You push through and yet the scale barely moves. The mental clarity people rave about never quite arrives. You start to wonder if fasting even works or if your body is somehow different. Here is the thing. For most people who struggle with fasting, the problem is not willpower. The problem is not their metabolism. The problem is that they are missing a crucial piece of the puzzle. Today, we are going to talk about something that many people overlook: the timing of your fast. Not just how long you fast, but when you fast. Because your body has its own schedule, its own internal clock that determines how it processes food, burns fat, and repairs itself. And if you understand that schedule, you will know exactly when your body burns fat most efficiently, when your cells start cleaning themselves, and when growth hormone peaks to protect your muscles. This is not just about skipping meals. This is about working with your biology instead of against it. Before we dive in, I need to remind you that this is educational content to help you understand your body better. If you have any medical conditions or are taking medications, please talk to your doctor before making changes to your eating pattern. Now let us start from the beginning. What actually happens inside your body when you stop eating? When you finish a meal, your body goes into processing mode. The food you just ate gets broken down into smaller components. Carbohydrates become glucose. This glucose enters your bloodstream and your blood sugar rises. In response, your pancreas releases a hormone called insulin. Insulin has one main job. It tells your cells to open up and let glucose in. Your cells use this glucose for energy. But here is the important part. When insulin levels are high, your body is in storage mode. Fat cannot be released from your fat cells. Your body is focused on processing and storing the energy you just consumed. This processing phase lasts about 4 to 6 hours, depending on what you ate. A meal high in carbohydrates and sugar keeps insulin elevated longer. A meal with more protein and fat allows insulin to drop faster. During the first 12 hours after your last meal, your body is still primarily running on the energy from that meal and the glucose stored in your liver. Your liver can store about 100 to 120 grams of glucose in a form called glycogen. Think of this as your short-term energy reserve. Here is why this matters. If you eat every 2 to 3 hours, if you snack throughout the day, if you have a sugary coffee in the morning and a sweet drink in the afternoon, your body never gets the chance to move past this phase. Insulin stays elevated. Fat stays locked in storage. Your body never switches to burning its own reserves. This is the situation most people find themselves in. They are constantly in processing mode, never in burning mode. Now, let us talk about what happens when you push past that 12-hour mark. Somewhere between 12 and 16 hours without food, something significant begins to happen. The glycogen stored in your liver starts running low. Your body needs to find another source of energy. And this is when it finally turns to your fat stores. When insulin drops low enough, your fat cells receive a signal to release their contents. Fatty acids enter your bloodstream and travel to your liver. Your liver then converts these fatty acids into molecules called ketones. Ketones are an alternative fuel source that your brain and muscles can use for energy. This transition from burning glucose to burning fat and producing ketones is often called the metabolic switch. And for most people, it happens somewhere around the 16-hour mark of fasting. At the same time, something else important is happening. your growth hormone levels start to rise significantly. Growth hormone plays two critical roles during fasting. First, it accelerates fat burning. Second, it protects your muscle tissue from being broken down. This is why proper fasting does not cause muscle loss the way many people fear. Your body has a built-in mechanism to preserve muscle while burning fat. This 12 to 16-hour window is the foundation of the popular 16-8 fasting method. You fast for 16 hours and eat within an 8-hour window. And now you understand why this timing works. It gives your body just enough time to deplete its glucose reserves and start tapping into fat. But what if you go longer, between 16 and 24 hours? The benefits deepen. Your body is now fully adapted to running on fat and ketones. But something else is starting to happen at the cellular level. A process called autophagy begins to activate more strongly. Autophagy is a word that comes from Greek meaning self-eating. It sounds alarming, but it is actually one of the most beneficial things your body can do. Here is how it works. When your body is not receiving protein from food, it needs to find protein from somewhere else. Instead of breaking down healthy muscle tissue, your body prioritizes recycling damaged and dysfunctional components inside your cells. Old proteins that are not folded correctly, mitochondria that are not producing energy efficiently, cellular debris that has accumulated over time, even bacteria and viruses that have invaded your cells. Your cells gather these damaged components, wrap them in a membrane structure called an autophagosome, and deliver them to another structure called the lysosome. The lysosome contains enzymes that break down these components into their basic building blocks, amino acids, and other molecules. These building blocks are then recycled to build new healthy proteins and cellular structures. Think of it as a deep cleaning process. Your cells are clearing out the old and damaged to make room for the new and functional. This process is constantly happening at a low level, but fasting significantly increases its activity. Why does this matter for your health? Because the accumulation of damaged proteins and dysfunctional cellular components is linked to aging and many diseases. When autophagy functions well, your cells stay cleaner and work more efficiently. When autophagy is suppressed, which happens when you eat constantly, throughout the day, cellular garbage accumulates. Research in animals has shown that autophagy becomes clearly measurable around 24 hours of fasting. In humans, the timing can vary depending on your metabolic health, activity level, and what you ate before starting your fast. But the principle remains the same. Extended fasting triggers this cellular renewal process. Now I want to ask you a question. If you had to choose between eating breakfast and skipping dinner, or skipping breakfast and eating a late dinner, which would you choose? Think about it and leave your answer in the comments. Keep watching to find out what the research says about these two options. Let us continue to the 24 to 48 hour range. After 24 hours, your body has fully adapted to the fasted state. It is no longer searching for food. It has settled into an efficient, fat-burning mode. And autophagy is now operating at a much higher level. Research published in the Journal of Clinical Investigation found that after 48 hours of fasting, 24-hour growth hormone production increased approximately 5-fold compared to normal levels. Other studies have documented growth hormone increases of 300% after shorter fasts and up to 1,250% after 5 days of fasting. This surge in growth hormone is not just about building muscle. It actively promotes fat breakdown while protecting lean tissue. It is your body's way of ensuring survival during periods without food. Burn the stored energy. Protect the functional tissue. During this phase, ketone levels rise substantially. Your brain, which typically relies heavily on glucose, is now running primarily on ketones. Many people report heightened mental clarity and focus during this period. This is not imagined. Ketones provide a steady, efficient fuel source for your neurons without the fluctuations that come from glucose metabolism. When you run on glucose, your energy and focus tend to rise and fall with your blood sugar levels. After a carbohydrate-heavy meal, you might feel a burst of energy followed by a crash. But ketones burn more evenly. They provide consistent fuel without the peaks and valleys. This is why many people find that once they push through the initial discomfort of fasting, they actually feel more alert and focused than when they were eating regularly. From an evolutionary perspective, this makes sense. Our ancestors did not always have access to food. When food was scarce, they needed to be sharp and focused to find their next meal. A brain that becomes foggy and slow during fasting would have been a survival disadvantage. So our bodies evolved to actually enhance cognitive function during periods without food. However, I need to be clear about something. Fasting beyond 24 hours is not appropriate for everyone. If you experience severe dizziness that does not go away with rest, if your heart starts racing or beating irregularly, if you feel confused or disoriented, these are signals that your body needs you to stop. Eat something light and consult a healthcare professional if symptoms persist. Fasting is meant to enhance your health, not compromise it. There is no prize for pushing through warning signs. Now let us talk about something that might change how you think about fasting entirely. The time of day when you eat. Everything we have discussed so far has been about how long you fast. But emerging research shows that when you eat might be just as important. Your body operates on a 24-hour internal clock called the circadian rhythm. This clock influences almost every biological process in your body, including how you process food. Here is what the research shows. Your sensitivity to insulin is highest in the morning and gradually decreases as the day progresses. By evening, your ability to process glucose has dropped by approximately 17% compared to the morning. This means the same meal eaten at 8 in the morning versus 8 in the evening will have different effects on your blood sugar and insulin response. In the early 2000s, a scientist named Dr. Sachin Panda at the Salk Institute in California was studying the circadian rhythms of the liver. He conducted an experiment with two groups of mice. Both groups were fed the exact same food, the same number of calories, the same high-fat diet. The only difference was timing. One group could eat whenever they wanted throughout the 24-hour day. The other group could only eat within an 8 to 12-hour window each day. The results surprised the entire research team. The mice that ate within the restricted time window were leaner, healthier, and showed fewer signs of metabolic disease despite eating the exact same amount of calories. This finding demonstrated something profound. It is not just what you eat or how much you eat. When you eat matters significantly. Dr. Panda later developed a smartphone app called My Circadian Clock to study eating patterns in real humans. What he discovered was concerning. More than 50% of users had eating windows that extended beyond 15 hours each day. Only 10% maintained an eating window of 12 hours or less. This constant eating pattern, spread throughout most of the day and into the night, disrupts the body's natural circadian rhythms and may contribute to metabolic problems even when total calorie intake is reasonable. But the evidence goes further. In 2018, a research team conducted a carefully controlled study published in the journal Cell Metabolism. They took men with prediabetes and fed them identical meals, identical calories, identical nutrients. The only variable was timing. One group ate from 8 in the morning to 2 in the afternoon, a 6-hour early eating window. The other group ate across a standard 12-hour period. After 5 weeks, the early eating group showed remarkable improvements. Their insulin sensitivity improved by 36%. Their blood pressure decreased. Their levels of oxidative stress dropped. And here is the striking part. They did not lose any weight. Same food, same calories, just different timing, completely different metabolic outcomes. This research suggests that eating earlier in the day and finishing earlier, giving your body a longer overnight fast, may provide metabolic benefits beyond what we see from fasting duration alone. So what does this mean practically? If you are choosing between skipping breakfast or skipping dinner, the science suggests that skipping dinner, or at least eating dinner much earlier, may offer greater metabolic benefits. Eating when your body is most prepared to process food during the morning and early afternoon, and then fasting through the evening and night, aligns with your natural circadian rhythm. This does not mean you need to finish eating by 2 in the afternoon, like the participants in the research study. Even shifting your last meal from 8 or 9 at night to 6 in the evening can make a meaningful difference. The goal is to give your body more fasting time during the night when your metabolism naturally slows down and your digestive system is designed to rest. Another practical consideration is consistency. Your body's circadian clock thrives on regularity. Eating at roughly the same times each day helps your body anticipate and prepare for food. It knows when to produce digestive enzymes, when to be more insulin sensitive, when to expect rest. Irregular eating patterns, eating at different times on weekdays versus weekends, for example, can disrupt these rhythms. Of course, this is not always practical for everyone. Work schedules, family dinners, social obligations, all of these factors matter. The best fasting schedule is one you can actually maintain consistently. But if you have flexibility, consider experimenting with earlier eating windows. Before we wrap up, let me be clear about who should not attempt extended fasting. If you are pregnant or breastfeeding, fasting is not appropriate. If you have a history of eating disorders, fasting can trigger harmful patterns and should be avoided. If you have insulin-dependent diabetes, you must work closely with your doctor before making any changes to your eating schedule. If you have chronic kidney disease, if you are underweight, if you are a whole child or teenager, extended fasting is not recommended. And if you take medications that require food, you need to coordinate with your healthcare provider. For everyone else, the signs that you should stop a fast immediately include severe dizziness that does not resolve with rest, heart palpitations, or irregular heartbeat, confusion or unusual difficulty concentrating, nausea or vomiting and weakness, so severe that you cannot perform normal daily activities. Fasting is a tool to improve health. It is not a competition to see who can endure the most discomfort. Start with a 12-hour eating window. If that feels comfortable, gradually reduce to 10 hours, then 8 hours. There is no need to rush. So let us bring this all together. You now understand the timeline. The 12 to 16-hour mark is when fat burning truly begins and growth hormone starts to rise. The 16 to 24-hour range is when autophagy activates more strongly and your cells begin their deep cleaning process. The 24 to 48-hour window is when autophagy reaches its peak and growth hormone surges to protect your muscles while maximizing fat burning. But beyond duration, you now understand timing. Eating earlier in the day when your insulin sensitivity is highest, and fasting through the evening and night when your metabolism naturally slows, may enhance all of these benefits. Fasting is not about punishing your body. It is about giving your body the time it needs to do what it cannot do when constantly processing food. Burning stored fat, cleaning damaged cells, repairing and renewing. Some experts argue that as long as you fast for enough hours, the timing does not matter. Others say that circadian alignment is essential and cannot be ignored. Now you have the information from both perspectives. What do you think? Does duration matter more, or does timing matter more? Share your opinion in the comments. I also want to know about your current practice. How many hours is your current fasting window? And what time do you usually eat your first meal of the day? Leave your answers below. If you know someone who has been trying to fast but has not seen the results they expected, this video might be the missing piece they need. Share it with them. And if this content was helpful to you, please hit the like button and subscribe so you do not miss the next video. I will see you in the next one. When does your body actually start burning fat during intermittent fasting? Some people say 12 hours, others say 16, and some claim you need to fast for 24 hours or even longer before your body touches its fat stores. But what does science actually tell us? The truth is, the answer isn't as simple as a single number. It depends on your body, what you ate before fasting, and how you live your daily life. Today, we're going to walk through every stage of fasting from the very first hour all the way to 24 hours and beyond. I'll explain exactly what's happening inside your body at each point so you understand precisely when fat burning truly begins and how you can optimize your fasting for better results. Before we dive in, please remember that this is educational content, not medical advice. If you have any health conditions or concerns, talk to your doctor before starting any fasting routine. Now let's start with the basics. Your body runs on two main fuel sources, glucose and fat. Glucose is a simple sugar that comes from the carbohydrates you eat. When you have a meal with bread, rice, pasta, fruits, or anything with sugar, your body breaks it down into glucose. This glucose enters your bloodstream and becomes available for your cells to use as energy. Your body prefers to use glucose first. Why? Because glucose is quick and easy to convert into energy. It's the fast fuel. Your brain especially loves glucose and uses about 120 grams of it every single day. Here's something interesting. At any given moment, you only have about 4 to 5 grams of glucose floating in your blood. That's roughly 1 teaspoon of sugar. It's a very small amount, yet your body works extremely hard to keep it stable. If blood glucose drops too low, you feel weak, shaky, and confused. If it rises too high, it can damage your blood vessels and organs over time. So what happens when you eat more carbohydrates than you need right away? Your body doesn't waste it. Instead, it stores the extra glucose in your liver and muscles as something called glycogen. Think of glycogen as your body's short-term energy storage. Your liver can hold about 100 grams of glycogen and your muscles can store around 400 grams. This glycogen reserve is incredibly important. When you stop eating, your body first turns to this stored glycogen to maintain your blood sugar levels. Only after this reserve starts running low does your body begin looking for another fuel source. And that other fuel source is fat. Fat is your body's long-term energy storage. An average person carries somewhere between 50,000 to 100,000 calories worth of energy stored as body fat. That's an enormous reserve, enough to fuel your body for weeks or even months. But here's the catch. Your body won't tap into this fat storage until it has used up most of the glucose and glycogen first. This is why many people struggle to lose fat even when eating less. If they never reach the point where their body needs to use fat, The fat simply stays where it is, untouched. Now there's another crucial piece to this puzzle, and it's called insulin. Insulin is a hormone produced by your pancreas every time you eat. Its main job is to help move glucose from your blood into your cells, where it can be used for energy or stored for later. Here's the key point. When insulin levels are high, your body is in storage mode. It's focused on using and storing glucose, not burning fat. In fact, insulin sends a clear signal to your fat cells: hold on to the fat, we have enough energy coming in. As long as insulin remains elevated, your fat cells keep their doors locked. The fat stays inside no matter how much you want it gone. Only when insulin drops do your fat cells receive permission to release their stored energy. This is why eating frequently throughout the day, even if you're eating small amounts or so-called healthy snacks, can keep insulin elevated and prevent fat burning from ever truly starting. When you fast, you stop eating and your insulin levels begin to fall. After several hours without food, insulin drops to low levels. This is when your body starts getting the signal that it's okay to access fat stores. If you have insulin resistance, which is common in people who are overweight or have been eating a high-carb diet for years, your insulin levels may stay elevated longer. This means it takes more time for your body to switch to fat burning. But don't worry, this can improve with consistent fasting practice. A quick note here. If you have type 1 diabetes or type 2 diabetes and take insulin medication, please work with your doctor before attempting any fasting protocol. Managing insulin and fasting together requires careful medical supervision. So now that you understand the basics, let's walk through what actually happens, hour by hour, when you fast. During the first 4 hours after your last meal, your body is busy digesting. The food you ate is being broken down in your stomach and intestines, and glucose is flooding into your bloodstream. Insulin levels are high because your body needs to process all this incoming energy. During this phase, you're definitely not burning fat. Your body has plenty of glucose available, so it has no reason to look elsewhere for fuel. You might feel full, satisfied, and energized, or you might feel a bit sleepy if you ate a large meal heavy in carbohydrates. This post-meal drowsiness happens because blood flow shifts toward your digestive system and away from other areas. From hour 4 to hour 8, digestion is mostly complete. Your blood glucose levels start returning to normal and insulin begins to drop. Your body now turns to its glycogen reserves in the liver to maintain stable blood sugar. You might start feeling slightly hungry during this time. This is normal. Your stomach is empty and your body is sending signals asking for more food. But your energy is still stable because glycogen is providing a steady supply of glucose. At this stage, fat burning is starting in small amounts, but it's not significant yet. Your body is still primarily relying on glycogen. You're in a transitional state. Between hour 8 and hour 12, things start to shift more noticeably. Insulin continues to fall and reaches lower levels than it's been all day. Your liver glycogen is being used up steadily and may have dropped by half or more. Your body is now recognizing that glucose supplies are getting low. It begins increasing a process called lipolysis. This is simply the process of breaking down stored fat. During lipolysis, your fat cells release their contents, which include fatty acids and glycerol, into your bloodstream. These fatty acids can then travel to your muscles and other tissues to be used as fuel. You'll likely feel genuinely hungry during this window. This is often the hardest part for people new to fasting. The temptation to eat is strong, and your brain may tell you that you need food urgently. Many people give up around this point. But here's what's actually happening. Your body isn't in danger. It's simply not used to going this long without food. The hunger you feel is partly habit, partly hormones. If you push through, something interesting starts to happen. From hour 12 to hour 18, you enter what scientists call the metabolic switch. This is a term coined by Dr. Mark Mattson, a neuroscientist who spent decades studying fasting at the National Institute on Aging. His landmark research, published in the New England Journal of Medicine, describes this transition point, where your body shifts from using glucose as its primary fuel to using fat. During this phase, your liver glycogen is running very low. Your body ramps up fat burning significantly. Your liver starts converting fatty acids into molecules called ketones. Ketones are an alternative fuel that your body and brain can use efficiently when glucose is scarce. Here's something that surprises many people. Around this time, hunger often begins to fade. You would expect to feel more hungry as time goes on, but the opposite frequently happens. As ketones rise in your blood, they provide steady energy to your brain without the fluctuations that come from glucose. Many people report feeling clearer, more focused, and calmer during this phase. Some describe it as mental clarity they've never experienced before. This is also when your growth hormone levels start to rise significantly. We'll talk more about why this matters in a moment. Quick question for you. What's your usual fasting window? Drop a number in the comments. I'm curious how many of you might be right on the edge of this metabolic switch without even realizing it. Now let's continue to hours 18 through 24. This is when you're truly in fat-burning mode. By this point, your body has fully transitioned to using fat as its primary fuel source. Ketone levels in your blood rise to measurable levels, typically between 0.5 and 2.0 millimoles per liter. Your insulin is at baseline very low levels. The pathway for fat release is wide open. Growth hormone, which we mentioned earlier, surges dramatically during this window. Studies show that during a 24-hour fast, growth hormone can increase by 300 to 500% compared to normal levels. Some research has documented even higher increases, up to 300% in women and 2000% in men during extended fasts. What does growth hormone do? It helps preserve muscle mass and encourages your body to burn fat for fuel. This is crucial because it means fasting doesn't automatically lead to muscle loss. Your body has a built-in system to protect your muscles while accessing your fat stores. Many people feel surprisingly good during this phase. Energy becomes more stable without the ups and downs that come from eating sugar and processed carbohydrates. Mental clarity improves. Hunger may come in waves, but it's often manageable and passes quickly. This is the fat-burning zone that so many people are looking for. For those who continue fasting beyond 24 hours, the body goes even deeper into ketosis. Your brain can eventually derive up to 75% of its energy from ketones. A process called autophagy also begins to activate more strongly. Autophagy is your body's way of cleaning up damaged cells and recycling their components. It's like a deep cleaning system for your cells. This is one of the reasons extended fasting has been linked to longevity and cellular health in scientific research. However, fasting beyond 24 hours requires more caution. If you're considering longer fasts, it's wise to do your research, ensure proper hydration and electrolytes, and potentially seek guidance from a healthcare professional. Now, here's an important point. The timeline I just described isn't identical for everyone. Several factors influence how quickly your body switches to fat burning. First, what you eat before fasting matters enormously. If your last meal was heavy in carbohydrates and sugars, your glycogen stores will be completely full. This means it takes longer for your body to deplete them and switch to burning fat. You might not enter the metabolic switch until hour 18 or later. On the other hand, if you eat fewer carbohydrates and more protein and healthy fats, your glycogen stores won't be as full. Your body can transition to fat burning faster sometimes by several hours. This is why people who follow low-carb diets often find fasting easier. Their bodies are already accustomed to using fat for fuel, so the transition feels natural. Second, your physical activity level plays a role. Exercise uses up glycogen. A moderate workout can deplete your glycogen stores faster and push your body into fat-burning mode hours earlier than it would otherwise. Even a long walk can help. However, don't overdo intense exercise when you're new to fasting. Your body needs time to adapt to using fat for fuel during physical activity. Third, your metabolic health affects the timeline. People with insulin resistance, which is common in those who are overweight or have metabolic syndrome, may take longer to shift into fat burning. Their insulin levels stay elevated longer, keeping fat cells locked. The good news is that practicing intermittent fasting regularly can improve insulin sensitivity over time. So even if the switch takes longer for you at first, it often becomes easier and faster as your metabolism adapts over weeks and months. Finally, individual differences simply exist. Some people transition to fat burning after 12 hours. Others need 18 or 20 hours or even longer. Don't compare yourself to others. Pay attention to your own body's signals and how you feel. Let's talk more about something many people worry about: losing muscle during fasting. This concern makes sense. If the body is breaking down stored energy for fuel, couldn't it break down muscle too? The answer is that your body is smarter than you might think. It has a built-in protection system for muscle tissue during fasting, and it's incredibly effective. When you fast, your body dramatically increases production of growth hormone. As I mentioned earlier, this hormone can surge by several 100% during a 24-hour fast. Growth hormone sends a powerful signal to your body: burn fat for fuel, but protect the muscles. Leave the muscle tissue alone. Research from the Mayo Clinic has shown that growth hormone during fasting can reduce muscle protein breakdown by up to 50%. Your body actively works to preserve muscle while accessing fat stores. This makes perfect sense from an evolutionary perspective. Our ancestors regularly went through periods without food, sometimes for days at a time. If their bodies burned muscle every time they were hungry, they would have become too weak to hunt or gather food for the next meal. Humans wouldn't have survived as a species. So evolution designed our bodies to preserve muscle while burning fat during periods of food scarcity. Growth hormone is a key part of this survival mechanism. It's a gift from our ancestors that makes intermittent fasting not only safe but effective for improving body composition. Of course, this protection applies to intermittent fasting and short-term fasting. Extremely prolonged fasting lasting many days without proper nutrition or supervision can eventually lead to muscle breakdown. But for typical fasting windows of 16 to 24 hours, your muscles are well protected. Now let's discuss something that can make a real difference in your results: what you eat during your eating window and how you break your fast. During your eating window, whether you're doing 16C out OMAD or another protocol, what you choose to eat affects how efficiently your body burns fat during your next fasting period. Prioritize protein. Protein helps maintain your muscle mass and keeps you feeling full longer. Good sources include meat, fish, eggs, Greek yogurt, and tofu. Aim to include protein in every meal. Include healthy fats. Fats don't spike your insulin as much as carbohydrates do, so they support the metabolic benefits of fasting. Avocados, olive oil, nuts, seeds, and fatty fish like salmon are excellent choices. Eat plenty of non-starchy vegetables. These are high in fiber, low in calories, and packed with vitamins, minerals, and antioxidants. Think broccoli, spinach, kale, cabbage, cauliflower, peppers, and leafy greens. The fiber helps you feel satisfied and supports healthy digestion. Limit refined carbohydrates and sugar. The fewer processed carbs you eat, the less glycogen your body stores, and the faster you'll switch to fat burning during your next fast. This doesn't mean you can never eat carbohydrates. Just focus on choosing complex carbohydrates with fiber like vegetables and legumes rather than refined sugars, white bread, and processed foods. How you break your fast also matters more than many people realize. After many hours without eating, your digestive system needs time to wake up again. If you immediately eat a large, heavy meal, you might feel bloated, uncomfortable, or even nauseous. Your insulin will also spike sharply, which can undo some of the metabolic benefits you just achieved. Start gently. Water is essential, especially if you haven't been drinking enough. Bone broth or light soup can help with hydration and provide electrolytes that your body may need. Then move to easily digestible protein like eggs, fish, or chicken. Cooked vegetables are easier on your stomach than raw ones when breaking a fast. Avoid breaking your fast with sugary foods, fried foods, or heavily processed meals. These will cause your insulin to spike rapidly, potentially leading to energy crashes and increased hunger later. The goal isn't to eat perfectly or follow a rigid diet. It's to understand that what you eat influences how effective your next fasting period will be. Small improvements in your food choices can lead to significantly better results over time. Before we wrap up, let's quickly cover who should not practice intermittent fasting. If you're pregnant or breastfeeding, fasting is not recommended. Your body needs consistent nutrition during these times to support yourself and your baby. If you have a history of eating disorders or currently struggle with disordered eating, fasting can trigger unhealthy patterns and should be avoided. Please seek support from a healthcare professional instead. If you have type 1 diabetes or type 2 diabetes requiring insulin medication, you need to work closely with your doctor before attempting any fasting protocol. Insulin and fasting must be carefully managed together to avoid dangerous blood sugar fluctuations. Children and teenagers who are still growing should not fast. Their bodies need regular nutrition for proper development. If you're significantly underweight with a BMI below 18, why fasting could be harmful and is not appropriate for you. And for everyone practicing fasting, there are warning signs that mean you should stop immediately. Severe dizziness that doesn't improve when you sit down, a racing or pounding heartbeat, confusion or difficulty thinking clearly, extreme weakness that prevents you from functioning normally, nausea or vomiting. If any of these symptoms persist for more than 30 minutes, break your fast with something gentle and consult a healthcare professional if needed. Your body is sending you an important signal, and you should listen to it. So let's bring everything together. Fat burning during intermittent fasting isn't like flipping a light switch at one specific moment. It's a gradual process. Your body transitions through stages, moving from using glucose to using glycogen to finally tapping into your fat stores. For most people, significant fat burning begins somewhere between hour 12 and hour 18 when the metabolic switch occurs. By hour 18 to 24, you're typically in full fat burning mode with ketones providing fuel and growth hormone protecting your muscles. But remember, your timeline may be different. It depends on what you ate, how active you are, and your individual metabolism. And that's okay. The key is understanding the process so you can make informed decisions about your fasting practice. Understanding this process helps you fast smarter, not just longer. You don't need to suffer through endless hours of hunger without knowing why. You need to understand what's happening inside your body so you can work with it, not against it. Intermittent fasting isn't a battle with your body. It's a partnership. Now I'm curious. What surprised you most in this video? Was it the growth hormone surge, the timeline of glycogen depletion, or something else? Let me know in one word in the comments. And here's something to think about. Some experts say 16 hours of fasting is enough for most people to get meaningful benefits. Others argue you need 24 hours or more to see real results. Based on what you just learned about the metabolic switch and fat burning timeline, where do you stand? If you know someone who has been trying intermittent fasting but feeling frustrated with their results, share this video with them. Understanding when fat burning actually starts could be the missing piece they need. And if this video helped you understand your body better, subscribe to the channel so you don't miss upcoming videos on health fasting and the science of how your body works. Thanks for watching, and I'll see you in the next one. How to choose the right fast for you. Have you ever wondered, should I fast for 16 hours, 24 hours, or 72 hours? Which one is actually right for you? If you search online, you'll find hundreds of different answers. One person says 16 hours is enough. Another says you need at least 24 hours to see real benefits. Some even recommend fasting for 3 days straight. And everyone seems absolutely certain they're right. So who's actually right? Here's the truth that most people miss. There is no single correct number for everyone. Because at each time milestone, your body activates completely different biological programs. Fasting for 16 hours and fasting for 72 hours aren't just more and less of the same thing. They trigger entirely different switches inside you. And if you don't understand this, you might be fasting too short for your goals or pushing yourself way too hard when you don't need to. Today, we're going to walk through each time milestone, each biological switch that your body turns on, so you can choose the fasting duration that best matches your personal health goals. No more confusion, no more guessing. But first, I need to be clear. This is educational content, not medical advice. If you have any health conditions, please talk to your doctor before trying any fasting protocol. This is important. Now think of your body like a smart home with different switches. A light switch for the living room, a switch for the air conditioning, a switch for the security system. Each one does something completely different. Your body works the same way. When you stop eating, your body starts flipping switches in a specific order. First comes the fat-burning switch, then the cellular cleanup switch, then the gut repair switch, and finally, if you go far enough, the immune system regeneration switch. Each switch needs a certain amount of time to turn on. And once it's on, it keeps working until you eat again. Why does your body have these switches in the first place? Because our ancestors didn't have grocery stores open 24 hours a day. They regularly went through periods without food, sometimes days at a time. And the body had to adapt, not just to survive, but to actually function well during those times. These switches are an evolutionary legacy, millions of years old, and they're still working inside you right now, waiting to be activated. One important thing before we dive in, the time milestones I'm about to share, are averages from scientific research. Not everyone is the same. If you've been eating low carb before, your body might enter ketosis faster. If you have insulin resistance or carry more weight, it might take longer. Everyone's body responds differently based on their metabolic health, their diet history, and their genetics. So use these milestones as guidelines and not rigid rules. Pay attention to how your own body responds. All right, Let's walk through the timeline. In the first 12 hours after your last meal, your body is still in normal mode. Your digestive system finishes processing the food you ate. Insulin, the hormone that controls blood sugar, starts dropping gradually. This is the preparation phase. Your body hasn't changed much yet. It's using glycogen, which is stored sugar in your liver, to maintain energy. Think of glycogen as your body's backup battery. It keeps things running while your body figures out what's happening. You might feel a bit hungry toward the end of this phase, especially if you're not used to fasting. That's completely normal. Your body is just sending signals because it expects food at the usual times. These signals will quiet down. But this isn't when the important switches get flipped. The interesting stuff starts happening at the next milestone. Between hours 12 and 16, something significant begins. The glycogen in your liver has dropped by about half to two-thirds. Your body realizes that its sugar supply is running low and needs to find another energy source. This is a critical moment. This is when your liver starts doing something special. It breaks down stored fat and converts it into a fuel called ketones. What are ketones? Simply put, when your body doesn't have sugar to burn, it learns to burn fat instead. Ketones are the product of this fat-burning process, and your brain and other organs can use them for energy. It's like your body switching from gasoline to diesel. Different fuel, same engine, but some interesting changes in how everything runs. Research from Harvard shows that many people start producing ketones after about 12 hours. This actually happens naturally every night while you sleep, as long as you're not snacking at midnight. So if you've ever slept 8 hours and skipped a late dinner, you've already experienced mild ketosis without even knowing it. If your goal is simply to control your weight, improve insulin sensitivity, and start burning fat, this is the milestone you need. The popular 16-8 intermittent fasting method is based on this principle. You eat within an 8-hour window and fast for 16 hours. Simple and effective for many people. From hours 16 to 24, your body starts flipping additional important switches. This is where things get really interesting. First, ketones increase significantly. Your brain can now receive up to one-third of its energy from ketones instead of sugar. Many people report feeling clearer and more focused during this phase. That's not imagination. That's chemistry at work. Second, growth hormone starts surging potentially 2 to 5 times normal levels. Why does this matter? Growth hormone helps protect your muscles while your body burns fat. This is crucial. Your body is smart. It doesn't want to break down muscle for energy when there's plenty of fat available. Growth hormone is part of that protection system. Research published in the Journal of Clinical Investigation shows this hormone can increase up to 5-fold during extended fasting. There's something else happening to your brain at this stage. Research shows that fasting increases production of a protein called BDNF, which stands for brain-derived neurotrophic factor. What is BDNF? Think of it as fertilizer for your brain. BDNF helps nerve cells grow, create new connections, and protects your brain from damage. It supports learning and memory. This is the real scientific reason behind the mental clarity many people report when fasting. It's not just in their head. There's actual biology behind that sharper feeling. Third, and this is fascinating, a process called autophagy starts getting activated. What does autophagy mean? Very simply, when your cells don't receive food for an extended period, they start cleaning house internally. Damaged proteins, old cell parts that no longer work well, malfunctioning components. All of it gets broken down and recycled into new materials. Think of it as spring cleaning. Instead of buying new stuff, you repair and reuse what you already have. Your cells become more efficient, clearing out the junk that accumulates over time. If you want more effective fat loss, improved mental clarity, and want to start activating cellular self-repair, the 24-hour mark is your target. At the 24-hour mark, something special happens with your digestive system. And there's actual research that shows exactly how powerful this is. In 2018, researchers at MIT ran a simple experiment with surprising results. They had mice fast for 24 hours, then took stem cells from their intestines and grew them in lab dishes. Stem cells are the construction workers of your gut. They create new intestinal lining and help your gut repair itself. The result? Stem cells from mice that had fasted for 24 hours had double the regenerative capacity compared to mice eating normally. Double. And remarkably, this effect occurs in both young and old mice. Age didn't matter. The fasting activated the same regenerative program regardless. Professor Omar Yilmaz, who led the research, said, "It was very obvious that fasting had this really immense effect on the ability of intestinal crypts to form more organoids." How does this work? When you're not eating, your gut gets to rest. Energy normally used for digestion gets redirected toward repair. The cells switch from burning sugar to burning fat, and this metabolic transition activates a program that enhances stem cell regenerative capacity. Your gut literally starts rebuilding itself. Here's something important that many people overlook. Research from 2024, also from MIT, found that the strongest regeneration doesn't happen while you're fasting. It happens when you start eating again afterward. What does this mean? How you end your fasting cycle is just as important as the fasting itself. Breaking your fast properly slowly, starting with easily digestible foods, helps maximize the regeneration process. Breaking it wrong immediately, eating a large greasy meal can diminish some of the benefits you just created. So don't rush to the nearest burger joint when your fast ends. Be strategic about it. If you have digestive issues, irritable bowel syndrome, or want to reset your gut, the 24-hour mark and beyond is where you should aim. From hours 36 to 48, your body enters deep fat-burning mode. This is serious territory. At this point, glycogen is completely depleted. Your body now relies entirely on stored fat for fuel. Ketones are high. And importantly, your body starts accessing the more stubborn fat, visceral fat, the fat that's accumulated over years around your internal organs. Visceral fat is more dangerous than fat under your skin because it releases inflammatory substances throughout your body. It's linked to heart disease, diabetes, and other health problems. Extended fasting helps your body dig deep into this fat storage that's otherwise very difficult to access. There's a fascinating story that illustrates what happens when humans are forced to adapt to less food over an extended period. In 1991, 8 scientists were sealed inside Biosphere 2, a massive glass structure in the Arizona desert, designed to simulate self-sustaining life on another planet. Among them was Dr. Roy Walford, a 67-year-old aging expert from UCLA. The problem was, they couldn't grow enough food as planned. The sunlight through the glass wasn't strong enough. Walford convinced the group to follow a calorie-restricted diet, averaging only 1,750 to 2,100 calories per day, mostly from vegetables and grains, for 2 entire years. The result? All 8 people lost an average of 17% of their body weight. But more remarkably, blood pressure, blood sugar, cholesterol, and triglycerides all dropped at least 20% to extremely healthy levels. Their immune systems also showed improved function. This was one of the longest calorie restriction experiments on humans ever recorded, and it showed that when the body must adapt to having less energy, it becomes remarkably more efficient at using what it has. However, I need to emphasize, fasting 36 to 48 hours is not for beginners. You need experience with shorter fasts first. Your body needs to learn how to handle extended periods without food before you push it this far. Some people report mood and focus changes at this stage. Although there are popular theories about dopamine receptor reset circulating online, direct research on humans at the 48-hour mark is still limited. What we do know for certain is that ketones at high levels provide stable energy to your brain, and BDNF continues to increase. Both contribute to the feeling of mental clarity that many experienced fasters describe. And now we arrive at the most impressive milestone, 48 to 72 hours. Research from 2014 at the University of Southern California, led by Dr. Walter Longo, discovered something remarkable. Fasting for 72 hours activates a regeneration switch in the immune system. Here's how it works. During extended fasting, your body starts killing off old and damaged white blood cells. This sounds bad, but it's actually a signal to stem cells. An enzyme called pKa gets suppressed, and this unlocks stem cells to shift from a dormant state to a self-renewal state. They start multiplying and creating new, healthier immune cells. Dr. Longo described it as flipping a regenerative switch. The old worn-out immune cells get cleared away, and fresh ones take their place. In phase 1 and clinical trials, cancer patients who fasted for 72 hours before chemotherapy showed better immune system protection. Their bodies were better equipped to handle the treatment. But, and this is very important, fasting for 72 hours is not meant to be done at home on your own. This is only for people who already have extensive experience with shorter fasts, and it must be done under medical supervision. The risks at this duration are real, and you need professional guidance. Now, I want to take a minute to talk about special cases, because fasting isn't suitable for everyone in the same way. If you have heart disease, heart failure, or arrhythmia, you need to be especially careful. Fasting can change blood pressure and heart rate. If you're taking blood pressure medication, fasting might cause your blood pressure to drop too much. And if you've had a stent placed or heart surgery within the past 3 months, some research suggests fasting may increase the risk of cardiac events. Always talk to your cardiologist first. Your liver is the organ that produces ketones and glucose when you fast. If your liver isn't working well, whether from hepatitis, cirrhosis, or liver failure, extended fasting can be dangerous. A weak liver can't produce enough glucose to keep blood sugar stable, leading to serious hypoglycemia. If you have liver disease, avoid extended fasting and always have medical supervision. With chronic kidney disease, especially stage 3 or higher, fasting can cause dehydration and electrolyte imbalances, which weakened kidneys can't correct well. If you have kidney stones, absolutely avoid dry fasting where you don't drink water. Always drink enough water and check kidney function regularly. If you have a history of anorexia, bulimia, or binge eating disorder, be extremely cautious. Setting strict rules around eating times can re-trigger disordered behaviors. Scheduled fasting isn't always healthy for everyone. If you've recovered, talk to a mental health professional before trying any fasting protocol. Fasting can increase cortisol, the stress hormone, in the early stages. For some people with anxiety disorders, this can make things worse. If you're in this group, start with very short fasts, like 12 to 14 hours. Observe how your body and mood respond, and shorten or stop if anxiety increases. So we've walked through the biological switches your body turns on at each time milestone. Hours 12 to 16 fat burning begins. Hours 16 to 24 cellular cleanup and growth hormone surge. Hours 24 to 36 gut regeneration. Hours 36 to 48 deep fat burning. Hours 48 to 72 immune system reset. So what should you choose? If your goal is weight control and starting to burn fat, 16 hours is enough. If you want mental clarity and to begin cellular cleanup, aim for 24 hours. If you have digestive issues and want to reset your gut, 24 hours or more. If you want to burn stubborn fat accumulated over years, 36 to 48 hours, but only with prior experience. If you need to reset your immune system, 72 hours, but only with medical supervision. Most importantly, listen to your body. No time milestone is worth sacrificing your health. If your body sends warning signals like severe dizziness that won't go away, heart palpitations, confusion, or persistent vomiting, stop immediately. Your body knows its limits better than any study or guideline. Remember, fasting is a tool, not a religion. The goal isn't to push yourself to extremes or prove how tough you are. The goal is to give your body what it needs to heal, repair, and function at its best. Sometimes that means a simple 16-hour fast. Sometimes it means going longer. And sometimes it means not fasting at all and focusing on other aspects of your health. The beauty of understanding these biological switches is that you're no longer guessing. You know what happens at each milestone. You can match your fasting duration to your specific goals. That's powerful knowledge. Now I want to hear from you. What's your main health goal right now? Is it fat loss, mental clarity, gut health, or immune support? Comment below, and I'll tell you which milestone fits best for your situation. And if you know someone who keeps asking, which fast should I do, share this video with them. It might save them weeks of confusion. Some doctors say you should never fast beyond 24 hours without supervision. Others point to research showing the biggest benefits happen at 48 to 72 hours. Where do you stand on this debate? Imagine your body has a built-in cleaning system. It hunts down damaged cells, recycles broken parts, and clears out the garbage before it becomes dangerous. This process is called autophagy. And for years, people believed it was one of the most powerful ways to prevent cancer. But now, everywhere you look online, people are saying the opposite. That autophagy might actually help cancer cells survive. That fasting could backfire if you already have cancer. So if you're someone who fasts for health, or you're a cancer survivor doing everything you can to stay healthy, this is terrifying. Just when you thought you were doing something good for your body, now you're not sure anymore. So which is it? Does autophagy kill cancer cells or fuel them? Today, we're going to settle this once and for all. And I promise you, by the end of this video, you'll understand exactly what's happening inside your body and why the answer isn't what most people think. We're going to look at real research, real communities, and real science that will change how you think about this topic forever. This is educational content, not medical advice. If you have any health concerns, especially regarding cancer, always consult your healthcare provider first. Now here's what makes this topic so confusing. Autophagy isn't simply good or bad. It plays two completely different roles depending on the situation. Think of it like fire. In your fireplace, fire keeps you warm and safe. It's useful. It's protective. But that same fire in the wrong place can burn down your entire house. The fire itself isn't the problem. Context is everything. In healthy cells before cancer develops, autophagy acts like a quality control system. It constantly patrols your cells, finds damaged proteins, broken organelles, and cellular waste, then breaks them down and recycles the useful parts. But in established tumors, especially when they're starved of nutrients, some cancer cells try to hijack this same process to survive. This is why headlines seem to contradict each other. One study says autophagy prevents cancer. Another says it helps tumors grow. Both can be true because they're studying completely different situations. The confusion comes from mixing up prevention and treatment, from confusing what happens in a laboratory dish with what happens in a living, breathing human body. And this is just the beginning of the story. But here's where things get really interesting. There's a community of people who've given us remarkable proof of what happens when growth signals stay low for an entire lifetime. In the remote mountain villages of southern Ecuador, nestled high in the Andes, there lives a group of about 100 people who are unlike anyone else on Earth. They stand on average just 4 feet tall. They have a rare genetic condition called Laron syndrome, caused by a mutation that prevents their bodies from responding to growth hormone. Scientists have been studying this community since 1988. And here's what caught their attention. Despite the fact that most of them struggle with obesity, something remarkable happened over 22 years of careful medical observation. Not a single one of them developed cancer. 0 cases. Not 1 case of diabetes either. Meanwhile, their relatives living in the same villages, eating the same food, breathing the same mountain air, sharing the same water, had a cancer rate of 17% and a diabetes rate of 5%. The difference wasn't lifestyle. It wasn't diet. It wasn't environment. It was biology. People with Laron syndrome have extremely low levels of something called IGF-1, which stands for insulin-like growth factor 1. Think of IGF-1 as fertilizer for your cells. When levels are high, cells get the signal to grow, multiply, and divide. That's great when you're young and developing. Your body needs those signals to build bone, muscle, and tissue. But cancer cells absolutely love this signal. It tells them exactly what they want to hear. Grow, grow, grow. The people of Ecuador have the fertilizer turned way down. And without that constant growth signal, cancer simply doesn't take root. Dr. Walter Longo, a longevity researcher at the University of Southern California, has been working with this community for years. He called them the perfect natural experiment. It's something scientists could never design in a laboratory. You couldn't ethically create a population with this mutation, but nature did it, and it's teaching us something profound. And here's why this matters for you. When you fast, your IGF-1 levels drop significantly. Studies show that a 72-hour fast can reduce IGF-1 by up to 70%, while increasing IGF-BP1, a binding protein that further reduces IGF-1's activity by 11-fold. You're not born with the Laron mutation, but fasting allows you to temporarily create a similar metabolic environment, one where growth signals quiet down and cancer cells lose one of their favorite fuels. This is the first piece of the puzzle. Now let's look at what autophagy itself does inside your cells. Every single day, tens of thousands of things go wrong in your DNA. Scientists estimate around 70,000 molecular lesions occur in each cell every single day. Little errors, tiny typos in your genetic code, damage from normal metabolism, from oxidative stress, from just being alive. Each one of those could potentially become cancer, but most never do. Your body has systems in place to catch these mistakes before they spiral out of control. DNA repair mechanisms fix the errors. Immune cells patrol for abnormal cells. and autophagy cleans up the damaged components that could cause problems. Think of it this way. Imagine P62 as cellular garbage. It's a protein that accumulates when damaged parts pile up inside your cells. Autophagy is the garbage truck that comes regularly to collect it. When the truck shows up on schedule, everything stays clean. Damaged proteins get recycled. Broken mitochondria get removed. Misfolded proteins get cleared away. The cell stays healthy and functional. But when the garbage truck doesn't come, things start to pile up. And that garbage isn't just ugly. It causes inflammation. It produces reactive oxygen species that damage DNA. It creates oxidative stress that accelerates aging. It creates exactly the kind of environment where cancer can begin. There's a gene called Beclin-1 that's essential for autophagy to work properly. Scientists discovered something fascinating about this gene. It's also a tumor suppressor. When researchers studied mice that were missing one copy of Beclin-1, those mice developed tumors at much higher rates than normal mice. They were prone to lung cancer, liver cancer, and lymphomas. In humans, reduced Beclin-1 expression has been found in about 50% of ovarian cancers, 30% of breast cancers, and significant portions of prostate cancers. The pattern is clear. When autophagy works well, it helps prevent cancer by keeping cells clean and removing damaged components before they become dangerous. Your body is doing this right now. As you listen to this, autophagy is patrolling your cells, taking out the trash, maintaining order. This is autophagy as your ally. So if autophagy prevents cancer, why are people saying it might help cancer cells survive? Here's where the confusion started. In laboratory studies, scientists observed something troubling. Certain types of cancer cells, particularly pancreatic and lung cancer cells, seem to use autophagy to survive when they were starved of nutrients or hit with chemotherapy drugs. They basically went into survival mode. When resources got scarce, these cancer cells ramped up autophagy to recycle their own components and keep going. And this made headlines. Suddenly people were worried. Should I avoid triggering autophagy if I'm concerned about cancer? Is fasting dangerous? But here's what those headlines missed. A petri dish is not a human body. In a laboratory dish, you have cancer cells floating in a simple solution. No immune system hunting them down. No hormones regulating their environment. No complex signaling networks. Just isolated cells trying to survive. In a real human body, everything is connected. There are hormones, immune cells, inflammation signals, oxygen gradients, ketones, and countless repair mechanisms all working together at once. It's a full ecosystem. When you fast, you're not just flipping one switch called autophagy. You're triggering a whole body metabolic shift that changes everything. Hormones change, immune cells activate, inflammation drops, ketones rise, growth signals fall. And in that ecosystem, the rules are completely different from what happens in a petri dish. Let's talk about what really happens when you fast and why it creates such a hostile environment for cancer cells. Almost 100 years ago, a German scientist named Otto Warburg noticed something strange about cancer cells. They consumed enormous amounts of glucose compared to normal tissue. The rate was stunning, sometimes 10 to 20 times higher than surrounding healthy cells. Even when oxygen was plentiful, cancer cells converted glucose to lactate through a process called fermentation. Normal cells don't do this when oxygen is available. They use their mitochondria to extract far more energy from each glucose molecule through a process called oxidative phosphorylation. But cancer cells seem stuck in this inefficient glucose-hungry mode. This became known as the Warburg effect, and it reveals a critical weakness. Cancer cells are metabolically inflexible. They've become addicted to sugar. Their mitochondria are often damaged or dysfunctional. They've lost the ability to efficiently switch between fuel sources. They're like cars that can only run on premium gasoline. They've forgotten how to use anything else. Your healthy cells, on the other hand, are hybrids. When glucose is available, they use it efficiently. But when glucose drops and ketones rise, they switch fuels seamlessly. They adapt, they survive, they thrive. This is where fasting creates what researchers call metabolic checkmate. It's a brilliant term because it captures exactly what's happening. In chess, checkmate means your opponent has no good moves left. Every option leads to defeat. That's what fasting does to cancer cells. When you fast, multiple things happen at once. Blood glucose drops. Cancer cells start losing their primary fuel source. They begin to starve. IGF-1 drops dramatically, just like in those Ecuadorian villagers. The growth signal that cancer loves gets turned way down. Insulin drops. This makes autophagy more selective, targeting damaged and dysfunctional cells first. Your body's cleanup crew gets smarter about what to remove. Ketones rise. Your liver produces these molecules from fat and healthy cells. Use them efficiently for energy. But most cancer cells cannot. Their damaged mitochondria can't make the switch. They're stuck waiting for sugar that isn't coming. Immune function improves. Studies show fasting can trigger regeneration of white blood cells, making your body better at detecting and eliminating abnormal cells. This isn't just one move against cancer. It's 5 moves happening simultaneously. And cancer cells, because of their mutations and metabolic inflexibility, cannot adapt to all of them at once. This is why what happens in a petri dish doesn't predict what happens in a living body. The petri dish only shows one variable. The body shows the whole picture. Now here's what gets really exciting. Researchers have been studying what happens when you combine fasting with cancer treatment. Dr. Walter Longo's team discovered something they call differential stress resistance. It's one of the most elegant findings in cancer research. When you fast, healthy cells and cancer cells respond in completely opposite ways. Here's how it works. Your healthy cells receive the signal that nutrients are low. They immediately shift into a protected mode. They slow down division. They activate repair mechanisms. They focus on maintenance. They hunker down and wait for conditions to improve. This is a survival program that's been refined over millions of years of evolution. Your ancestors who could protect their healthy cells during famine survived to pass on their genes. Those who couldn't did not. But cancer cells have a fundamental problem. Their oncogenes, the very mutations that make them cancerous in the first place, keep them locked in growth mode. They cannot hear the signal to slow down and protect themselves. They keep trying to divide, keep demanding resources, keep pushing forward even when there's nothing to fuel them. It's like a car with the accelerator stuck to the floor even when the gas tank is empty. So when chemotherapy hits, here's what happens. Healthy cells are in protected mode. They've battened down the hatches. They're shielded from the toxic effects of the drugs. They weather the storm. Cancer cells are completely exposed. They're still trying to grow. They're vulnerable. They're like deer frozen in headlights. This differential response has been tested in human trials. In a study called the DIRECT trial, published in Nature Communications in 2020, researchers gave one group of breast cancer patients a fasting mimicking diet before and during chemotherapy. The other group ate normally. The results showed that patients who fasted had better responses to treatment. More cancer cells died. Healthy cells were more protected. In mouse studies, combining fasting with chemotherapy produced something remarkable. 20 to 60% of mice with metastatic cancer became completely cancer-free. With chemotherapy alone, that number was close to zero. With fasting alone, it was also close to zero. But together, they created a synergy that neither could achieve on its own. Now, this absolutely does not mean cancer patients should start fasting without guidance. This is cutting-edge research that requires careful medical supervision. But it shows us something profound about how the body works. Fasting doesn't just trigger autophagy in isolation. It creates an environment where healthy cells become more resilient and cancer cells become more vulnerable. So let's put all of this together. Does autophagy kill cancer cells or fuel them? The answer is, it depends entirely on context. In a healthy body, before cancer develops, autophagy is one of your most powerful protective mechanisms. It clears damaged cells before they become dangerous. It removes the cellular garbage that causes inflammation and DNA damage. It's your body's quality control system working around the clock to keep you healthy. But autophagy doesn't work alone. When you fast, you're not just activating one mechanism. You're creating an entire metabolic environment that evolution designed over millions of years. Lower glucose, lower IGF-1, higher ketones, stronger immunity, more selective cellular cleanup. It's a coordinated response that makes healthy cells stronger and cancer cells weaker. The question isn't really whether autophagy is friend or foe. The question is, what environment are you creating inside your body? An environment where damaged cells get cleaned up before they become dangerous, or an environment flooded with sugar and growth signals where abnormal cells can thrive. If you have cancer or are undergoing treatment, this isn't something to experiment with on your own. Work closely with your oncologist. The research is promising, but it requires careful medical guidance. But if you're healthy and thinking about fasting as a preventive strategy, the science suggests you're working with your body's natural intelligence, not against it. You're tapping into the same protective mechanisms that have kept the people of Ecuador cancer-free for decades. You're creating conditions where your cells can do what they evolved to do. Clean house, remove damage, stay healthy. Some doctors remain cautious about extended fasting. Others point to the growing body of research showing remarkable benefits. This is one of the most fascinating debates in health science right now. And it's a debate worth having because the stakes couldn't be higher. Cancer affects millions of people every year. And understanding how our bodies naturally defend against it could change everything. Where do you stand? What's your biggest takeaway from this? Drop one word in the comments that describes how you see autophagy now. If someone you know has been confused about fasting and cancer, and honestly, the internet has made this incredibly confusing, share this video with them. They deserve to see the complete picture, not just the scary headlines. And if you want to understand the real science behind what's happening inside your body, subscribe. We go deep on topics like this every week. Your body is far more intelligent than you might realize. It has protective systems in place that have been refined over millions of years of evolution. Autophagy is one of them. It's not a trend. It's not a fad. It's ancient biological wisdom encoded in every cell of your body. The people of Ecuador didn't choose their protection. They were born with it. But you have something they don't. You have the knowledge to create similar conditions through the choices you make. Through when you eat and when you don't. Through giving your body the space it needs to clean, repair, and protect itself. That's not just science, That's power. And now you understand how to work with it, not against it. You've probably heard the word autophagy somewhere before, maybe from a health video, an article, or from someone practicing intermittent fasting. But what is it really? And more importantly, if you're fasting, how long do you actually need to fast before autophagy kicks in? 16 hours, 24 hours, 48 hours. Today we're going to find out. Before we start, a quick note. This is educational content, not medical advice. If you have health conditions, please consult a professional before trying extended fasting. All right, let's begin with the most basic question. What exactly is autophagy? The word comes from Greek. Auto means self. Phagy means eating. Put them together. Self-eating. Sounds scary, right? But don't worry. This is actually one of the smartest things your body can do. Think of it this way. Your body is like a house you live in every day. You cook in it, move around in it, live your life in it. And over time, things pile up. Old furniture, broken stuff in the corners, dust in places you don't notice. At first, you don't see it. Everything still works fine. But week after week, month after month, the house gets heavier, more cluttered, less efficient. Now imagine your house has a built-in cleaning crew, an automatic system that kicks in when conditions are right. A system that knows exactly what to keep, what to throw out, and what to recycle. That's exactly what autophagy is. The ultimate cellular spring cleaning. Inside your cells over time, waste accumulates. Damaged proteins lying around. Tiny parts inside your cells called organelles getting old and worn out. Mitochondria, your cellular power plants becoming less efficient. Sometimes even viruses or bacteria hiding inside. When autophagy activates your cells, recognize these things. They wrap up the damaged parts, break them down, and recycle them into new building materials. Your cells aren't eating healthy parts. They're cleaning up what's broken to build something new. It's like having a sophisticated recycling system. Take what's broken, break it down further, and reuse the materials to create brand new structures. And this isn't just theory. In 2016, Japanese scientist Yoshinori Ohsumi won the Nobel Prize in Medicine for his research on autophagy. He spent decades studying this process, starting with a simple experiment. He starved baker's yeast cells and watched what happened under a microscope. What he saw changed biology forever. When deprived of nutrients, cells started eating their own damaged parts to survive. And he discovered the genes controlling this process. Genes that humans have too. This is globally recognized science, not pseudoscience. Hard biology. Osumi's discovery opened an entirely new field of research. Scientists now know that autophagy plays a role in fighting infections, preventing cancer, and protecting against neurodegenerative diseases like Alzheimer's and Parkinson's. When autophagy works well, your cells stay clean and efficient. When it doesn't work well, damaged components pile up, and that accumulation is linked to aging and disease. So the next question is, how do you activate this process? And how long do you need to fast? To answer that, we need to understand what actually happens inside your body when you stop eating. The first thing to understand is this. Autophagy is not an on-off switch. It's not like you fast for 16 needs, 16 hours click, and autophagy turns on. It's more like a dimmer switch. You know those switches that let you gradually brighten a light? Autophagy works like that. The longer you fast, the brighter it gets. And there's no single magic number for everyone. Every body is different. But science gives us a pretty clear picture of this journey. Let's walk through it stage by stage. Stage 1. 0 to 12 hours. This is the warm-up phase. When you've just eaten, your body has glucose readily available from your meal. Insulin is released to manage energy, pushing glucose into cells. In the first hours after eating, your body uses this glucose. As it runs low, your liver starts releasing stored glycogen. Glycogen is glucose stored in your liver and muscles. About 100 grams in the liver alone. That's roughly 400 calories of backup energy. Think of it like a reserve fuel tank. Main tank runs low. The body switches to reserves. During this stage, autophagy isn't really active yet. The cleaning crew is still sleeping. Your body doesn't feel the need to activate deep cleaning mode. Why would it? There's still plenty of fuel coming in. You might feel a little hungry, but everything still runs normally. Business as usual. Stage 2, 12 to 18 hours. This is when the shift begins. Glycogen stores are running low. Insulin drops significantly, and your body realizes something important. Okay, glucose is running out. Time to find another fuel source. At this point, your body starts switching to burning fat for fuel. Your liver begins producing molecules called ketones, an alternative energy source made from fat. Think of it like this. The main fuel tank is almost empty. Your body is preparing to switch to backup power your stored fat. And here's the beautiful thing. Your body has been doing this for millions of years. It knows exactly how to make this switch. Autophagy starts waking up. The dimmer switch begins to glow faintly. But it's still slow, not running at full power yet. You might feel more noticeably hungry during this phase. That's your body adjusting, learning to switch fuel sources. It's a transition period, and this is where things start getting interesting. Stage 3, 18 to 24 hours. This is the critical window. Ketones are now being produced steadily. And here's the amazing part. Your brain can use ketones as fuel. In fact, the brain runs quite well on ketones. Some research suggests it's actually a cleaner, more stable energy source for the brain. Your brain isn't starving, it's adapting. Insulin is now very low, and this is crucial. When insulin is low, the genes related to autophagy get activated more clearly. Low insulin is like a green light for your cells to start cleaning. The dimmer switch is getting brighter. The cleaning crew is starting to work for real. Cells begin sweeping up damaged proteins, worn-out organelles, cellular debris that normally slows things down. And many people feel the change at this stage. Mental clarity. The brain shifts from foggy to sharp. Focus improves. Ideas come more easily. You stop thinking about food constantly. It's like cleaning your house's electrical wiring. Everything works better, faster, more clearly. One more thing. Hunger might actually decrease. Sounds strange, right? Fasting longer, but feeling less hungry. But it's real. When your body fully switches to burning fat and producing ketones, it stops screaming for glucose. It's found a stable energy source. No more energy roller coasters, just calm, steady fuel. Have you ever felt this moment when your brain suddenly becomes sharper during a fast? Let me know in the comments. This mental shift isn't placebo, it's evolution. Ancient humans needed to stay sharp when food was scarce. They needed to think clearly to find their next meal. Your body in fasting mode is returning to that primal alertness. It's working harder, faster, and smarter. Stage 4, 24 to 48 hours. This is the high activity zone. Autophagy is now running at high levels. Cells throughout your body are actively cleaning. And here's something fascinating. Not just body cells, but brain cells too. For a long time, scientists believed the brain was protected from fasting-induced autophagy. They thought it was a metabolically privileged site that escaped these effects. They were wrong. Animal studies show something remarkable. After 48 hours of fasting, autophagy in brain cells increases dramatically. We're talking about a significant jump. The brain isn't being starved, It's being cleaned, renewed. This might explain why fasting has been practiced for mental clarity across cultures for thousands of years. Buddhist monks, Ramadan fasting, ancient Greek philosophers, different cultures, same observation. Fasting sharpens the mind. Additionally, a protein called BDNF increases during this phase. Scientists sometimes call BDNF fertilizer for the brain because it helps nerve cells grow, connect, and survive. It supports learning memory and the growth of new neural connections. The immune system also begins a reset process. Old inefficient immune cells get cleared out, making room for new ones. Your body is literally renewing itself from the inside. This is the golden zone for many people. The dimmer switch is shining bright. But this is also when you need to listen to your body carefully. Fasting 12 hours or more isn't for everyone. If you're new to intermittent fasting, don't rush into this zone. Your body needs time to adapt. Build up gradually. Your energy during this phase might be surprisingly high. Some people feel more alert than usual, or you might feel tired. Everyone reacts differently. The key is listening to your body, not following a rigid number someone else gave you. Stage 5, 48 hours and beyond. This is advanced territory. Autophagy continues at high levels. Stem cells, the cells capable of regenerating tissue, start getting activated. The immune system may undergo deeper regeneration. White blood cell production can increase. This is the zone of profound changes in the body. But I need to be direct. This is not a zone for beginners. If you don't have experience with extended fasting, don't attempt 48 hours or longer without proper preparation and knowledge. Your body needs electrolytes, minerals like sodium, potassium, magnesium. It needs proper hydration. It needs you to recognize warning signs. If you feel severe dizziness that won't pass, unusual rapid heartbeat, confusion, or genuinely unwell, not just hungry, but unwell, stop. That's your body telling you something important. Don't push through it. Don't be a hero. And one more critical point. How you end your fast matters just as much as how you start it. After a long time without food, your digestive system is resting. Digestive enzymes are low. Your gut is sensitive. Eating too fast, too much, can shock your body. This is called refeeding, and doing it wrong can undo much of the benefit. Start gently, small portions, easily digestible foods, then gradually increase. Don't dive into a huge feast right after a long fast. The way you break your fast can either lock in the benefits or undo much of what you've achieved. Take it seriously. Also, certain people should not attempt extended fasting at all. Pregnant or breastfeeding women, people with a history of eating disorders, those on medications that require food, people with serious blood sugar issues. If any of these apply to you, please talk to a healthcare professional first. So to summarize the timeline, for most people, the 18 to 36-hour zone is where autophagy works effectively. But some people feel changes earlier, some later. And that brings us to an important question. Why is the timing different for each person? There are 5 main factors that affect your autophagy timing. First, your metabolic rate. Some people have a Ferrari engine. They burn fuel fast. Glycogen depletes early, maybe after just 12 to 14 hours. Others have an economy engine, slow and steady. It might take 18 to 20 hours to deplete glycogen. Not fair, but that's how bodies work. Second, your usual diet. If you eat lots of carbohydrates every day, rice, bread, pasta, your body is used to running on glucose. It's become a sugar burner. Switching to fat burning takes longer, it's harder. But if you already eat low carb, your body switches quickly. like changing a TV channel. Easy and fast. Third, your activity level. People who exercise regularly have bigger glycogen fuel tanks. Muscles store more glycogen. So if you work out 5 days a week, it might take 18 to 20 hours to deplete glycogen. Less active. Smaller fuel tank depletes faster. Ironically, being sedentary gives you a small advantage here. Fourth, your age. As we get older, the autophagy system slows down, like old machinery starting up slower. Research suggests autophagy naturally declines with age, which may contribute to the accumulation of cellular damage over time. But this is also why fasting might be more important as you age. It helps wake up a sleeping system. It gives your body the signal to start cleaning again. That's actually good news. You can support your autophagy system at any age. Fifth, your fasting experience. The first time you fast, your body panics. Where's the food? What's happening? It resists. That's natural. But after several times, your body learns. It becomes metabolically flexible, switches to fat burning faster, activates autophagy more smoothly, like a well-oiled machine. Scientists call this metabolic flexibility. This is one of the rare areas where experience actually gives you a superpower. The more you practice intelligently, the better your body gets at it. Here's the encouraging part. You can train this. Every time you complete a fast, your body gets a little better at making the switch, a little faster at entering the autophagy zone. It's like building a muscle. The more you use it, the stronger it gets. So if your first few fasts feel difficult, that's normal. Your body is learning. Keep going. It gets easier. So how do you know when your body has entered the autophagy zone? You don't have a lab at home. You can't measure autophagy directly, but your body talks to you if you know how to listen. There are three indirect signals that you might be in the autophagy zone. Signal 1, mental clarity. Your brain shifts from foggy to sharp. You stop thinking about food constantly. Focus improves. Ideas come more easily. It's not magic, it's chemistry. This is a sign ketones are fueling your brain. And when ketones are active, autophagy is usually active too. Signal 2, stable energy. At first, when fasting, your energy might go up and down like a roller coaster. Alert one moment, tired the next. Then suddenly, everything stabilizes. Steady, even, no more midday crashes. Your body has found a stable energy source from fat. Signal 3, hunger fades. Sounds strange, but it's real. Intense hunger at first, then it just disappears. Your body stops screaming for food. It's found a way to fuel itself. Please note, these are indirect signs, not direct proof that autophagy is happening. But they show your body is in a state where autophagy typically occurs. The connection between these signs and autophagy isn't coincidental. Ketosis and autophagy are tightly linked. They are both responses to the same metabolic state. Low insulin, low glucose, the body in conservation and repair mode. When you notice these signals, there's a high chance your cellular cleaning crew is hard at work. Now, let's return to our original question. How long should you fast to trigger autophagy? There's no single magic number. There's your number. For most people, the 18 to 36-hour zone is where autophagy works effectively. But you need to experiment, observe, and adjust for your own body. Start with shorter fasts. Notice how you feel. Pay attention to when those signals appear for you. That's your body giving you data. Use it. Autophagy isn't a new trend. It's a survival mechanism that's been around for millions of years. Our ancestors didn't eat 3 meals a day plus 2 snacks. They experienced periods of abundance and scarcity. The human body evolved to adapt to that. And your body still remembers how to do this. Fasting isn't self-punishment. It's reconnecting with ancient wisdom your body still carries. Think about it. For most of human history, we didn't have refrigerators. We didn't have 24-hour convenience stores. Food was uncertain. And our bodies developed sophisticated systems to thrive in that uncertainty. Autophagy is one of those systems. It's your body's way of making the most of scarce resources, cleaning house when there's time, preparing for the next challenge. When you fast, you're not depriving yourself. You're giving your body permission to do what it already knows how to do. Next time you fast, don't just watch the clock. Listen to your body. And let your cells do what they're programmed to do. Clean, regenerate, renew. After how many hours of fasting do you feel your body changing? Share your timing in the comments. I'm genuinely curious. If this video helped you understand autophagy, share it with someone who's exploring fasting. Subscribe so you don't miss future videos on the science behind fasting and optimizing your health. Next up, the most common mistakes when breaking a fast and how to avoid them. See you soon. Your belly fat has a secret timer. It won't release a single gram until your body passes through 3 biological checkpoints. And here's the part that nobody talks about. Most people quit at checkpoint 2, just 24 hours before the fat-burning explosion actually begins. Ever notice how your face slims down, your arms get leaner, but that stubborn belly fat just sits there like it's protecting state secrets? There's a biological reason for this. And once you understand it, everything about fat loss suddenly makes sense. Your belly fat cells have what scientists call triple locked doors, while the fat on your arms has screen doors. It's not fair, but it's evolution. Think about it. When you start any diet or fast, where does the weight come off first? Your face, your fingers, maybe your chest. But that belly, it holds on like your life depends on it. Because thousands of years ago, it actually did. This is educational content based on scientific research, not medical advice. Always consult your healthcare professional before starting any fasting protocol, especially if you're pregnant. Breastfeeding have a history of eating disorders, type 1 diabetes, or take medications requiring food. What you're about to discover is the exact timeline of when your body finally decides to unlock those belly fat stores. Hour by hour, we'll track what's happening inside you. And at hour 48, something so remarkable happens that it won a Japanese scientist the Nobel Prize. But most people never make it that far. They quit right before the magic starts. So let's dive into those first crucial 12 hours where absolutely nothing seems to be happening, but your body is actually preparing for something extraordinary. In the first 12 hours of not eating, your body doesn't even realize you're fasting yet. It thinks you just missed a meal, maybe got busy, forgot to eat lunch. No big deal. Your blood sugar starts dropping slightly, and your liver says, "I got this," releasing stored glucose from its glycogen reserves. Think of glycogen as your body's spare change jar. Quick energy kept around for exactly these moments. But here's what's fascinating. Even in these early hours, your growth hormone is already starting to rise. Just a little at first, like someone slowly turning up a dimmer switch. This hormone is about to become your best friend because its job is to protect your muscles while targeting fat. It's like having a bodyguard that only lets the bad guys get hurt. Your insulin levels are still relatively high from your last meal, and insulin is like a strict security guard at the fat cell gates. As long as insulin is elevated, those gates stay locked. Your belly fat cells, they have triple locked doors with deadbolts. The fat on your face and arms. Screen doors that a breeze could open. Meanwhile, your brain is completely unfazed. It's running on glucose like it always does, happy as can be. Your energy feels normal, maybe even good. If you usually experience post-meal crashes, you might think, this is easy, I could do this forever. But your body hasn't even started the real process yet. The hunger waves come and go, usually lasting about 20 minutes each. That's your stomach releasing ghrelin, the hunger hormone, on its usual schedule. It's like your stomach has an alarm clock that goes off at mealtimes, whether you need food or not. But if you wait those 20 minutes out, something interesting happens. The hunger just disappears, like it was never there. By hour 12, your body is starting to get suspicious. The emergency meeting is about to begin. Between hours 12 and 24, your body shifts from casual concern to active investigation. The liver's glycogen stores are running lower, like a gas tank approaching quarter full. Your body starts having what I call an emergency board meeting. All the hormones gather around and ask, is this a real food shortage or just a delayed meal? This is when norepinephrine enters the conversation. The same hormone that gives you focus during stress starts rising, making you feel surprisingly alert. Ancient humans needed this. When food was scarce, they couldn't afford to feel sluggish. They needed sharp minds to find their next meal. Your body is literally giving you biological coffee. Growth hormone really starts surging, now increasing up to 5 times normal levels. This isn't just protecting muscle anymore, it's actively signaling fat cells to start preparing for mobilization. But remember those triple locked doors on your belly fat. They're still locked tight. Insulin is dropping, but it hasn't dropped enough to open all 3 locks yet. Your liver starts producing small amounts of ketones like a backup generator doing a test run. These ketones are about to become premium fuel for your brain, but right now they're just trickling in. Your brain doesn't need them yet. It's still got enough glucose, but the machinery is warming up. Some people feel dizzy or lightheaded around hour 18. That's completely normal. Your body is switching fuel systems like a hybrid car, switching from gas to electric. If you feel dizzy and it passes within 30 minutes, you're fine. If it doesn't, especially if you have a racing heart or confusion, that's your body saying stop. Don't be a hero. Listen to those signals. The fascinating part. While all this is happening, your belly fat is still just sitting there watching. It knows something's up, but it's not worried yet. It's seen 24-hour periods without food before. No need to panic. But what it doesn't know is that in the next 24 sub 24 hours, everything is about to change. Here's where most people quit. Right at hour 24, when they're standing at the door of transformation, they turn around and go home. Because they don't know what's about to happen next. At hour 24, your body makes a decision. This isn't just a missed meal anymore. This is real. The metabolic switch begins to flip, and this is where the Nobel Prize-winning science comes in. In 2016, Japanese scientist Yoshinori Ohsumi won the Nobel Prize for discovering autophagy. The word literally means self-eating. But don't worry, it's the good kind. Your cells start breaking down and recycling damaged proteins, dysfunctional organelles, and cellular junk that's been accumulating for years. Think of it as Marie Kondo arriving in your cells asking each damaged protein, do you spark joy? If not, it gets recycled into fuel. This process peaks between 24 and 48 hours. Your cells are literally eating their broken parts and turning them into energy. Old mitochondria that weren't working properly, recycled. Misfolded proteins that could eventually cause disease, broken down and repurposed. It's the most sophisticated cleaning system imaginable, and it's happening in trillions of cells simultaneously. Meanwhile, insulin has finally dropped low enough to start opening those locks on your belly fat cells. Not all three locks yet, but the first one clicks open around hour 30. The second lock starts loosening around hour 36. Your body is preparing to access its long-term storage vault. Ketone production shifts from a trickle to a steady stream. Your brain starts using these ketones alongside glucose, and something remarkable happens. Many people report mental clarity unlike anything they've experienced before. It's not placebo. Ketones are a more efficient fuel for your brain than glucose. It's like your brain has been running on regular gas your whole life, and suddenly someone puts in premium. But here's what nobody tells you. Between hours 36 and 48, you might feel worse before you feel better. Some call it the fasting flu. Mild headaches, fatigue, irritability. Your body is literally rewiring its metabolism. Every cell is learning to run on fat instead of sugar. It's like teaching an entire city to speak a new language overnight. If you're still going at this point, if you're properly hydrated with adequate electrolytes, and if you don't have any medical conditions that make fasting dangerous, pushing through this phase leads to something extraordinary. Because at hour 48, the third lock on your belly fat cells finally opens. Hour 48 is when the magic happens. All three locks on your belly fat cells are finally open. Insulin is now low enough that visceral fat, that dangerous fat wrapped around your organs, starts mobilizing. And here's the surprising part. Visceral fat actually burns faster than the subcutaneous fat under your skin. Think of visceral fat as an active volcano and subcutaneous fat as a dormant mountain. The volcano is metabolically active, constantly releasing inflammatory signals affecting your hormones. When your body finally decides to tap into it, it burns hot and fast. That's why some people notice their blood pressure improving and their blood sugar stabilizing before they see major changes in the mirror. A University of Southern California study found something remarkable at the 72-hour mark. The researchers discovered that fasting for 3 days completely regenerated the entire immune system. Old, damaged white blood cells died off, and stem cells created brand new ones. It's like getting a biological software update, except instead of your phone, it's your immune system getting upgraded. Your brain is now running primarily on ketones, and brain-derived neurotrophic factor, or BDNF, starts increasing. Think of BDNF as fertilizer for your brain. It promotes the growth of new neurons, protects existing ones, and improves the connections between them. This is why many people report not just clarity but actual improved problem-solving ability during extended fasting. The belly fat that seemed so stubborn, it's now releasing fatty acids into your bloodstream at an accelerated rate. Your liver is converting these fatty acids into ketones so efficiently that your ketone levels might be 10 to 20 times higher than normal. You've become a fat-burning machine, and your belly fat is the primary fuel source. But here's the evolutionary twist nobody talks about. Our ancestors, who could maintain mental sharpness while their belly fat burned, were the ones who survived food scarcity. They could still hunt, still think strategically, still protect their families. The ones whose brains got foggy when belly fat burned. They didn't pass on their genes. You're literally experiencing an ancient survival mechanism that kept our species alive. What surprised you more, that belly fat has triple locked doors, or that it takes 48 hours to finally get all the keys? Some people experience a phenomenon around hour 60 called the fasting high. Euphoria, boundless energy, almost supernatural mental clarity. This isn't imagination. Your body is producing compounds similar to endorphins. You're literally getting high on your own belly fat burning. After 72 hours, you've entered what researchers call the steady state of fat oxidation. Your body has fully adapted to burning fat as its primary fuel. The belly fat that seemed impossible to lose is now your body's preferred energy source. Every hour you continue, you're primarily burning stored fat, especially from the abdominal region. The USC study I mentioned earlier, the participants who fasted for 72 hours didn't just regenerate immune cells. They showed improved markers for aging, reduced inflammation, and enhanced cellular cleanup. One researcher described it as flipping a regenerative switch. Your body isn't just burning belly fat anymore. It's renovating itself at the cellular level. But let's be real about safety here. Extended fasting beyond 72 hours isn't for everyone. If you have any history of eating disorders, if you're underweight, taking medications that require food, or have any chronic health conditions, this is where medical supervision becomes essential. Your body's wisdom includes knowing when to stop. The growth hormone that's been protecting your muscles this entire time is now at maximum levels, up to 5 times normal. This is why studies show that fasting preserves lean mass better than traditional calorie restriction. Your body has millions of years of evolution telling it, save the muscle, burn the fat. It knows muscle is what will help you find your next meal. Here's something that might blow your mind. Our ancestors regularly went 3 to 5 days without food. Not by choice, but by circumstance. A failed hunt, seasonal food scarcity, migration between territories. The humans who could efficiently switch to belly fat, burning after 48 to 72 hours, were the ones who survived. Those who couldn't make this metabolic switch or whose belly fat wouldn't release its stores didn't make it. You're not fighting against your body when you fast. You're actually activating an ancient program written into your DNA. Your belly fat isn't stubborn because your body hates you. It's stubborn because your body is trying to protect you, saving that energy for what it perceives as a potential famine. But once you pass those 3 checkpoints, once you wait out that biological timer, your body trusts you enough to open the vault. And when it does, the transformation isn't just physical, it's metabolic, cellular, and even psychological. So here's the thing about your belly fat. It's not stubborn, it's strategic, it's not broken. It's following a program older than civilization itself. Now you know the timer: 24 hours for the first lock, 48 hours for the second, 72 hours for the complete system to activate. The question isn't whether your body can do this. It absolutely can. The question is whether you'll quit at checkpoint 2, like most people do, or whether you'll wait for that third lock to open. Because now, you know, something most people never learn. The breakthrough isn't weeks away. It's usually just 24 hours after the moment most people give up. Some doctors say never fast beyond 24 hours. They point to the stress on the body, the potential for electrolyte imbalances, the risk for certain populations. Other researchers point to studies showing profound benefits at 48, 72, even 120 hours. The immune regeneration, the autophagy, the metabolic flexibility. Where do you stand in this debate? Are you team 24 or team 72? Drop the number of hours you fasted in the comments below. Let's see who's actually unlocked all 3 belly fat doors. And be honest, how many of you quit right around that 24-hour mark, not knowing you were just 1 day away from the breakthrough? If you found this biological timeline fascinating, subscribe for more science that challenges what you think you know about your body. Hit the notification bell if you want to understand the hidden biology most people never discover. And if someone you know keeps quitting diets after a week wondering why their belly fat won't budge, share this with them. They need to know about the timer. Next up, watch this. What happens to loose skin during extended fasting? The autophagy secret. Because once that belly fat starts burning, you'll want to know what happens to everything that's left behind. Your body remembers how to do this. The program is already installed. The timer is set. The only question left is,